This module explores the role of scenarios in crowd management. To start, let's look at the learning objectives for this module. In this section, we will focus on understanding what scenarios are and why they are important in event crowd management. The main objective is to develop a basic understanding of how scenarios are defined and used when planning and managing events. We will explore the role that scenarios play in identifying potential risks and supporting decision-making before and during an event. We will also look at the different types of scenarios that are considered during risk assessment, including both expected situations and less likely but potentially high-impact events. Finally, we will discuss how to define relevant scenarios that can help event organizers prepare for challenges and manage crowds safely and effectively. In crowd management, our goal is to reduce the likelihood of problems occurring and increase the chance of successful and safe events. To do this, we need to think ahead and consider what might happen in the future. For example, imagine that the weather turns out to be better than expected, resulting in 20% more visitors than originally planned. The question then becomes, can the venue and its surroundings safely accommodate this increase? Or are there areas that may become overcrowded and potentially unsafe? Because we cannot predict the future with certainty, we need a way to deal with uncertainty. One effective approach is to develop and analyze different possible futures, which we call scenarios. Of course, it is possible to prepare for every possible situation. Instead, we focus on the uncertainties that are most relevant to our objectives and create scenarios around them. As a result, different people and organizations may consider different scenarios, depending on their roles, responsibilities, and goals. These scenarios are then incorporated into the crowd management plan. They help organizers anticipate potential challenges, support better decision-making, and provide valuable material for training and preparing stakeholders before the event takes place. When defining scenarios, it's usually helpful to begin with the baseline scenario. This is the situation in which everything proceeds as planned, the ideal or happy flow of the event. At a high level, events are commonly divided into three main stages: ingress, circulation, and egress. Ingress refers to people arriving at the event. Circulation covers the time when visitors are participating in and moving around the event. And egress describes the process of people leaving the venue. Within each of these stages, crowd behavior and crowd characteristics tend to be relatively consistent. This makes it easier to analyze the expected conditions and identify potential risks. For each stage, we can consider different operating conditions. These include normal operation, where everything functions as expected, peak load situations, where visitor numbers or movement reach their highest levels, and disturbances, where unexpected events or disruptions affect the crowd. By examining each stage under these different conditions, we can better understand potential challenges and prepare appropriate management strategies. After defining the baseline scenario, the first non-baseline scenario that should be considered for almost every event is evacuation. Evacuation planning is essential because it provides a general response strategy for a wide range of worst-case situations. The most common example is a fire, but evacuation may also be required in response to other serious incidents, such as a terrorist attack or a major safety threat. In many cases, building permits and event permits include specific requirements regarding evacuation. These requirements often define the maximum amount of time that an evacuation may take to ensure that all visitors can reach safety quickly. Because fire risk is one of the primary reasons for these regulations, evacuation plans are typically reviewed and enforced by fire departments and other safety authorities. For these reasons, an evacuation scenario should almost always be included in an event's crowd management plan. It is also good practice to consider evacuation at different moments during the event, as crowd size, crowd distribution, and availability routes may vary over time. This helps ensure that the evacuation strategy remains effective under different conditions. The other scenarios that should be considered depend on the main sources of uncertainty that are relevant to a specific event. This slide highlights several possible sources of uncertainty, but it is important to remember that the list is not exhaustive. Every event has its own characteristics and therefore its own unique set of risks and uncertainties that maybe need to addressed. For example, at a music festival with multiple stages, one relevant scenario could be the last-minute cancellation of a popular artist. If a large number of visitors had planned to attend that performance, they would suddenly need to redistribute themselves across the venue. This could create unexpected crowd movements and increased pressure at other stages, potentially leading to congestions or overcrowding. Another example comes from SAIL 2025. One area of concern was the increasing use of drones. Compared to the previous edition 10 years earlier, drones had become much more common, and many visitors were expected to use them to capture aerial photographs and videos of the event. However, drones can pose safety risks if operations lose control. For example, because of strong winds, gusts, or collisions with other objects. In such situations, a drone could fall into a crowd and cause injuries. In addition, SAIL has a significant maritime component, which means that conditions on the water play a much larger role than they do for most events. Factors such as weather, water traffic, and vessel movement can all influence safety and crowd management, making them important sources of uncertainty to consider when developing scenarios. One practical way to decide which scenario should be included in your plans is to follow a structured risk assessment process. The first step is to identify the main risk factors that are relevant to your event. The examples discussed on the previous slide can provide a useful starting point, but you should also consider any event-specific factors that could affect safety or operations. Next, evaluate each risk factor for every stage of the event: ingress, circulation, and egress. For each combination, estimate two things: the likelihood that something could go wrong and the potential impact if it does. A common approach is to score both likelihood and impact on a scale from 1 to 5, where higher scores indicate greater risk. Once those scores have been assigned, they can be combined to create an overall risk score. This can be done by either adding the scores together or multiplying them, depending on the method used by your organization. The resulting scores help prioritize the scenarios. Those with the highest scores represent the most significant risks and are therefore the scenarios that will likely require the greatest attention in planning, preparation, and mitigation measures. There are several methods that can be used to develop and analyze scenarios. Examples include storyboarding, brainstorming sessions, and simulation-based approaches. In this example, we will focus on the process of creating and using a simulation. The first step is to define the objectives of the simulation. Depending on the purpose, the simulation may be used for optimization, visualization, prediction, or a combination of these goals. Next, a two-dimensional or three-dimensional model of the physical event is created. This model should include both fixed obstacles, such as buildings and barriers, and dynamic obstacles that may change during the event. Once the environment has been modeled, the walkable areas are identified. These are the spaces where pedestrians can move throughout the event. The next step is to define the different types of pedestrians that will be represented in the model. This includes characteristics such as walking speed, movement patterns, and specific behaviors that may influence crowd dynamics. After that, the baseline scenario is established. This represents the normal event conditions and serves as the reference point for comparing other scenarios. The desired output parameters must then be determined. Examples include crowd density, pedestrian counts, crowd flow rates, and the format in which results will be presented, such as images, videos, graphs, or heat maps. Before using the model for decision-making, it is important to validate and calibrate it. This ensures that the simulation accurately reflects real-world conditions and produces reliable results. Once the model has been validated, the selected scenarios can be executed and analyzed. Finally, the results are reviewed and used to draw initial conclusions. These findings should be communicated to the relevant stakeholders and used to improve plans and procedures. Scenario development is an iterative process, meaning that the model, assumptions, and plans can be refined repeatedly as new insights become available. Sail Amsterdam is widely recognized as the largest freely accessible event in the Netherlands, attracting millions of visitors to the waterfront along the A. While it is a spectacular celebration of maritime heritage, it also represents significant challenges in crowd management, mobility, and public safety. As a partner of Sail 2025, uCrowds is proud to contribute innovative technologies that help manage this complexity. Our main contribution is SimCrowds, a real-time simulation platform capable of simulating hundreds of thousands of pedestrians within dynamic and realistic urban environments. Through our collaboration with the Field Lab Sail 2025 and by integrating with platforms such as Map Gallery and KPN's Data Services Hub, we can stream simulation results directly into GIS viewers. This provides safety authorities and operational teams with real-time insight into both current and expected crowd densities across the event area. The platform has been successfully tested during large-scale events such as Remembrance Day and King's Day in Amsterdam. Using a detailed 3D environment created from photogrammetry data from Kavel team and enriched with semantic information from Spot Info, we were able to run realistic scenarios in real time. Examples included road closures, route changes, and shifts in pedestrian flows. The value of this technology goes beyond visualization. It enables crisis coordinators, event organizers, and mobility teams to make faster and more informed decisions based on data. To further strengthen integration with city systems, we developed uConnect, our latest component for connecting simulations directly to digital twins. By supporting OGC standards such as WMS and WFS, uConnect ensures seamless interoperability with existing GIS infrastructures. This allows simulations results to be incorporated into operational platforms that are already used by municipalities and safety organizations. Through these technologies, we directly support the ambitions of Sail 2025. Creating an event that is safe, accessible, and enjoyable for everyone involved. Sail is a unique occasion that brings enormous energy and excitement to Amsterdam, but it also places exceptional demands on the city's infrastructure and public spaces. By combining advanced simulation technology, real-time data, and close collaboration between stakeholders, we helped ensure that Amsterdam remains not only a spectacular destination, but also a safe and well-organized environment for millions of visitors. To put the concepts from this module into practice, we propose 2 training activities that focus on identifying and evaluating scenarios from different perspectives. The first activity is a simple exercise. Imagine you are organizing a birthday party at your home. Your task is to identify 5 scenarios that should be considered to ensure the safety of your guests. Think about possible situations that could affect the event and how they might be managed. Next, expand the exercise by considering a different setting. What if the party takes place in a local bar and 50 people are invited? How do the risks change? Which new scenarios become relevant and which risks become more significant because of the larger number of people and a different environment? The second activity is a group exercise designed to highlight how different stakeholders view risk and safety. Each group member should take on one of the following roles: event organizer, crowd manager, fire safety inspector, or venue owner. While you are asked to consider a small music event lasting one evening with fewer than 1,000 visitors. From the perspective of your assigned role, identify the 3 most important risk scenarios that should be included in the event planning process. Once everyone has completed the exercise, compare the scenarios identified by each role. Discuss the differences and similarities. What is each stakeholder primarily concerned about? How do their responsibilities influence the risks they prioritize? This exercise demonstrates that the scenario selection is closely linked to the objectives and responsibilities of the people involved. For the purpose of this activity, the roles are defined as follows. The event organizer is the person primarily responsible for the event as a whole, including its successful and safe execution. The crowd manager is responsible for both the planning and operational aspects of crowd management. This includes developing and implementing the crowd management plan and ensuring safe crowd movement throughout the event. The fire safety inspector focuses on fire-related risks and emergency preparedness. This role is particularly concerned with evacuation procedures and ensuring that safety regulations, including maximum evacuation times, are met. Finally, the venue owner is responsible for the location itself and may have concerns related to property, infrastructure, liability, and the overall safe operation of the venue. By comparing these perspectives, participants can gain a deeper understanding of how different stakeholders contribute to event safety and why effective crowd management requires collaboration between multiple disciplines.